a little bit, or we may not. We'll see how much time we got. This is composition of functions. You guys should be familiar with notation. Two functions donated, and a composite function donated by f of g, or f composed of g. I taught you this in Algebra 2. I always had to do a rewrite on these. F composed of g is equivalent to f, and then the parentheses g of x. Does that mean something? Hopefully. Can you tell me in words what f of g of x means to you? Anybody? Of g of x and f of x. It's fine with me. Wherever you see an x, there it is. So it's just composition of functions today, which hopefully won't be too bad. This is kind of interesting stuff. It's tables and finding values. I don't know why when I wrote these notes out, I defined f and g with a set of points. And it makes a whole lot more sense if you're looking at the table. Like we're supposed to find f of 1. You can do that by looking at points. F of 1 says x is what? F of 1 says x equals 1. Find y. That's what it says, right? Now, you can do that with the order pairs up there. Look at function f, the top one. When x is 1, what is y? There you go. But I want to move this over to a table. And I've got all the x values assigned here. I just want to write them down in the table what things are. So when x is negative 3, does f have a value? Does f have a value when x is negative 3? No. Does g? Yeah, g has a value. When x is negative 2, does f have a value? 3. Does g have a value? No. There's no entry in g for x value negative 3. When x is negative 1, f has a value of 1, and g has a value of negative 2. When x is 0, I see a 0 there. I see a 2 here on g. When x is 1, negative 1. X is 2, negative 3, 2. And when x is 3, that guy's 1. Did I throw anybody off doing that? The reason I'm trying to move this over table is one, your homework's got table, and you can see it. First thing you see is table, right? That's how you make tables. Anyways, g of negative 1. Who knows what g of negative 1 is now that we have a nice table? Negative 2. It says find x where x is negative 1, and then look at g, negative 2. C is g composed of f of 1. I think notation helps here. How would you rewrite g of f of 1? G of f of 1 was already found, wasn't it? It was negative 1. So literally all we do is we do a substitution step. And then we're tasked with finding g of negative 1, which I think Emily just shared with us a few seconds ago. What was it? Maybe it wasn't Emily. No. Was it Taylor? Was it you? I don't know. I had my back to you. Example D is f of g of 1. Porter, what's g of 1? It's nothing. Uh-oh. That's wrong. Nonsense, right? E is g of f of 0. That one's probably doable. Maybe. What's f of 0, kids? F of 0 is 0. So we do a little replacement. We're actually tasked with finding g of 0. G of 0 is doable. Asia, what's g of 0? 2. And that's how you read tables. Anybody have any issues with that? Usually throws kids off in algebra 2. Just a little bit until they see it done and it clicks. All right, find some composite functions. We don't have to do all of these. Let's do B and maybe D. I don't know if you guys do this, but do any of you guys actually do like I do, and when you see G of F of 1, you rewrite it? No? You don't? I do. Do that because it makes it easier on your memory. I'm exhausted. The first thing I need to actually find is what? F of 1. Which means that everywhere we see an X in F, what's it become? 1. I don't know that you need to write all this down. F of 1 is twice a 1 squared plus a 3. What does that create? It does not create a 6. Nor does it create a 7. It's 5. G of 5, right? I don't know. You got on that? Yeah. 1 squared is 1, times 2 is 2, times 2. Yeah. And then we're tasked with finding G of what? 5. We found that piece right there to be 5. That's going to be quite a bit bigger, and it ain't going to be 7 either. What's 5 cubed create? 125, right? Times 4. 500 plus 1. 501. That was B. The example I care to do is D. D is G composed of G composed of negative 1. Something you plug back in yourself. So we're going to find G of negative 1. Why don't you guys spend a few seconds of your life finding G of negative 1? What'd you guys get for G of negative 1? Negative 3? Negative 3 is correct. Brenton found G of negative 1 to be a negative 3. We're just going to replace that. So now we're searching G of negative 3. You can plug that into G or F. I know some kids have some confusion on this. You guys do so much F of G stuff that you just kind of default from that. You plug a negative 3 in and cube it, you get negative 27. Multiply that by 4. I believe you're to negative 102. No, you're not. Negative 1.2, right? That's wrong too, isn't it? Is the final answer negative 127? No, I must be off here. 107. Thank you. All right, besides me, is anybody else having problems with that? Apparently it's Monday. You guys want to do any more of those? The plugging in numbers and stuff like that, that's usually pretty easy. Here's where it starts getting a little harder. And it's not the actual compositions when you start talking about domain of composite functions. And the first two examples we have, their domain is anything we have to worry about, so we just do them. A is find f of g. I'll write this out the long way and hope it understands. First off, that means you're finding f of g of x. Right? What is g of x? 4x plus 1. That's literally what g of x is. Now, the notation like this is every x in f becomes 4x plus 1. That's all it means. Most of you know that. Only a handful of you that I remember last year struggled with this. Most of you know this. So it's going to take us a minute. There's an x. What's it become? 4x plus 1. Right, because there's two of them, and I got to square it. You still see kids that'll do things like this. Shouldn't be seeing that anymore. I can give you the right answer or the wrong answer. I wrote it wrong. Right before you subtract. Alright, so that's what you got in front of you. This should be a breeze after that question you took on that last test. By the way, the reason I didn't go over that test is because there's still a couple of them on it. But they weren't too bad of grades. How do you handle 4x plus 1 squared? You FOIL it. Okay? You FOIL it. You're going to write 4x plus 1 times 4x plus 1. What do you get when you multiply 4x plus 1 by itself? Go ahead, Ellen. Do that. Negative. All right, we'll combine like terms. Now, I'm not going to write a new line here where I distribute the 2. You know, if you double 16x squared, how many x squared you got? You got 32 of them. If you double 8x, I think you got 16 of them, but what do you have to take away from that 16? 4 of them. 12x. Double that 1, you got 2, and then you have to take away 1, which takes you back to 1, and you have to add 4, which takes you to what? 5. Well, now we got to talk about the domain. Let's see here. We probably need to have a better definition. Actually, what do you guys know about domain? Can you give me a definition of domain? Nobody can give me a definition of domain? Nobody? What happens in public education? Years and years of crappy math teachers. Me being one of them. Domain of a function. All values of x that create a y value. All the value of x has to do is create a y value. Only 2 situations. Domain is not all real numbers. In other words, negative infinity to positive infinity. You might know the situations that would cause your domain not to be everything. You just dealt with it in section 5. Vertical asymptotes, right? How are vertical asymptotes created? How are vertical asymptotes created? You try to divide by 0. That's it. It's one of them. So one case is when there are vertical asymptotes. And that covers 99% of all the problems out there. Because you can't divide by 0. We hadn't talked about the other one yet, and we won't talk about it today. But there's another situation that causes problems. What's the smallest number you can take the square root of and be real? Huh? 0? Yeah, could you throw the square root of -4, like if you had y equals root of x, and you let x be -4, would you see anything on a graph? No, because it's the xy axis, not the x imaginary axis. That's the other situation we have to worry about. All even roots must be at least greater than 0. It's only the even roots. It's the only two situations you ever have to worry about domain. We just got done with a whole unit on fractional or rational expressions, so we'll still see some of that today. And there's what you need to know about domain. Now, back to what I was working on. Could you give me an x value that thing would just puke and throw up and say I can't give you a y value? Is there any attempt to divide by 0? I don't see a divisor. Or do you see a square root? What's its domain? Negative infinity to positive infinity. Not a single number in this world that thing can't accept and spit back a y value. I mean, plus you should know it's negative infinity to positive infinity. It's the graph, or its graph is what shape? Problem. It's squared. Runs forever right, runs forever left. There's no asymptotes in that thing. Not a single one. Oh, there's another example for that one, wasn't there? Yeah, the other way around. The other one was g of f. All right, so everywhere I see an x and g, what's it become? 2x squared minus x plus 4, right? All of that? This one's going to be a lot easier than the last one, isn't it? You guys need me to work that out? What's its domain going to be? Unless you see a divisor or a square root, you don't worry about domain. It's everything. Everything. You guys clear on that? All right, so hopefully there's some fractions coming up. Ah, good, there are fractions. Good. All right, find f of g and f of f and the domain of the composite function. Before I even start, look at f. What's the one thing x can't be? X can't be 5. Why? You divide by 0. Look at g. What's the one thing that can't be there? -1. Why? I'm just going to make a little note here that x is not 5 and x is not -1. Now f of g that x right there that I'm pointing at, what's it going to become? Which is 2 over x plus 1. That x right there becomes 2 over x plus 1. 3 over, there's x, 2 over x plus 1, and then minus the 5. You see what happened? That's not what I want to do. All of that. Right there. Now, this is where you talk about domain. As soon as you form the function, you immediately talk about domain, or at least you try to start talking about it. Right there, when that function was created, its initial setup, what could x not have been? 5. At the moment of inception, if x is 5, this never going to happen. So you know that. We're going to kind of write that off to the side. I know right here that x cannot be. What'd you tell me? Huh? -1. At the moment of inception, there's no way x can be -1. You see that? What would have happened? We would have attempted to do what? Divide by 2. This function would have never got to grow up, kids. Now, we're not going to leave answers like that. Well, here's the other fun part. You know how to add two fractions? Now, here's the kind of rule you learned once upon a time. You may have used different letterings, but you give A what? D. You give C B. So you know the unified denominator of what? BD. 5 is sitting on an understood 1. What do I give the 2? I gave this AD, what do I give that 2? 1. Kind of, some kids like to think of it as cross multiplication. It is and it isn't, but that's kind of how it works. 2 times 1 is 2. There's a minus because there's a minus. What's that 5 giving? X plus 1. And the unified denominator is the product of x plus 1 and 1, which is? It's the product of x plus 1 and 1. I knew we were making too good time this morning. X plus 1. All right, you guys remember how you divide by a fraction? Multiply by the what? Reciprocal. So 3 sits over 1. It gets multiplied by, the new numerator becomes x plus 1. I'm going to clean this up. This will be a negative 5x minus 5 plus 2 minus 3. Any issues with that? Besides just those 5th grade math rules? So 3 times x plus 1 is 3x plus 3.
Mr. Ham?
Yes, ma'am.
Do you have any absent?
Yes, I do. Allison James. And I'm pretty sure that's it.
Okay, thank you.
1 times that negative 5x minus 3 is negative 5x minus 3. There's the end result. You need to check domain here too. I guarantee you if you graph this thing, it'll be a very flashing point. Guarantee you it will be. What would it be? Not 3/5. Negative 3/5. You know, kind of go back to what you're doing on that last exam. Hopefully you're saying negative 5x minus 3 cannot be 0. Add 3 divided by that negative 5. X cannot be negative 3/5. So there were two things x couldn't be. There was something at the moment of inception, and there was something when everything was said and done. Two things it couldn't be. Let's talk about what it couldn't be. We knew that we could not be negative 1, and we knew that we could not be negative 3/5. Write that out as an interval. Think about it. You're at negative infinity. You get to walk all the way to what? What comes first, negative 1 or negative 3/5? Negative 1. Walk all the way from negative infinity to negative 1. You got to jump that -1, and you get to keep walking on the other side of -1 until you run into what? Maybe -3/5. You jump that hole where that asymptote is there. You're on the immediate other side of -3/5. But is there any problem for the rest of your life whatsoever? So you can walk all the way to where? Okay. So that was a bunch of fun. Yeah? No? You want snow, don't you? You guys are already so far behind.
I don't even know what you did.
Well, some of you guys have already had dual enrollment. You're done with math. Some of you guys are not done with math.
That's why it should be improved.
You should have listened to your teacher your sophomore year and done everything that he told you to.
I'm confused, added about the multiplication. What? Why'd you set it up like that? I already learned it.
I added 2 fractions.
I know it, but you got 30, you got 2 minus.
That line's down right here. 3 is 3/1. X plus 1 moved up high. And -5 times x is -5x. -5 times 1 is -5. Add 2. I cleaned it up as I went. I really don't like taking a whole page notes. Should I?
No, I was just confused.
I'm just saying, if I need to write some more boards for this, I will. What's up next? F of F. Self-seating. All right, so now we're doing part B, F of X. Let's teach this like sex, like composition is just seating another function. Makes it pregnant. This thing's getting itself pregnant. What it's doing? It's seating itself. All right, so this X in F, what's it going to become? That little X right there. Itself. There's that X. What am I going to replace it with? 3 over X minus 5. And then I have the -5 off the side. Now, if you didn't like that whole adding of fractions, there's another way to do this. I taught this to you in Algebra 2. This is what we call a nested fraction. You can a nested fraction up real quick when multiplying by the LCD. The least common denominator. You have to have a handout and double. What is the LCD? No. X minus 5. If you look at this thing, 1, 2, 3 pieces, the only fraction is X, this piece right here. The least common denominator is X minus 5. Looking like that, that's fine. Take the entire function and multiply it by an X minus 5. Now, before I continue, I talked about this on the last one. At the moment of inception, you need to decide what X can be. X cannot be 5. As soon as you write it, you need to realize, right then and there, there's no way you can be 5. There'll be another one that shows up later, once you get this thing simplified and reduced. Now, when I taught this to you in Algebra 2, I just said it was distributive property. Distribute that thing to all 3 pieces. So, you go here. What's 3 times X minus 5? X minus 15. Over. Distribute here. What happens? Cancellation. There's an X minus 5 up high, there's an X minus 5 down low, which is 3. Minus, you go here. Any cancellations there? Minus 5x plus 25. So it does save you a little bit of time. Truth is, to be a strong suit, you need to know both. You can clean that up. 3x minus 15, negative 5x plus 28. Divided will factor in the numerator if you really wanted to, nobody really cares. Another value of x that you can't be is happening. There's a vertical asymptote. So look at that and see it. But it's there. What's that one thing you can't divide by? 0. You set up a two-step equation in your head. So not 0. You subtract 28 and divide by negative 5, right? What do you get? 4.
Oh, it's under 20.
Oh. That's at 28.
Oh.
X is not negative, positive 28 fifths. Boy, it's going to be one of those two answers. Huh? Alright, so somebody give me the domain as an interval. Negative infinity to where? 5 or 28 fifths, which one? No? 28 fifths is the smaller of the two. Union with what? Nope. You jumped at asymptote at 28 fifths. You're still really close to what? 28 fifths. There ain't no long distance jumper in there. It's short game. What's your girl?
That's 28 fifths smaller.
I know, we're going from negative 20, negative thing to the small
I
number.
it's 28 fifths smaller.
I don't know, somebody told me that. Who told me that?
I don't know.
Who told me 28 fifths? Girl, I was making fun of Emily being a girl. You didn't see my short girl jump there?
Whole paper.
You jump from 5. You're to 5, right? You're 5 to where? 28 fifths, which is actually pretty short in itself. And 28 fifths to infinity. Two wrongs still doesn't make it right. I was wrong, you were wrong. It doesn't make us both right. You are a woman, so you might get the benefit of the doubt, but that's about it. What's left in your notes? This will probably be where I stop. I'll probably do these last two examples. If you take calculus, one of the things we do in calculus is we kind of look at functions a little bit different. We use a lot of substitution techniques. And we would have problems like this when we start taking derivatives, and you wouldn't actually write something out 50 times. Do you imagine writing something out 50 times and figuring out what it is? It would take a few days, wouldn't it? You'd probably be wrong too. You'd probably screw up the very first time you did anything at all. The rest will be right except for that first step. But the idea here is we find two functions that create this through composition. Now, a lot of times what we'll do in calculus, and it almost always works this way, we'll let whatever has an action on it be u. In this case, we're talking about f. What are we trying to find here? Such that f made of g is h. All right, so this would be the inside function. Notice how x squared plus 1 is kind of inside the 50th power. I'll try to explain it that way. Since x to the second plus 1 is inside, it's g. Because what are they wanting? They're wanting f of g. Isn't g inside the notation? F is the action being performed on g. What's the action being performed? What are you raising that thing to? The 50th. So f is x to the 50th power. So I decide that f of x is x to the 50th. G of x is x to the second. Plus 1. Now would that work? Would that create f of g to match x squared plus 1 to the 50th power? Aaliyah says she sees it. Anybody else see it? Would f of g of x create x squared plus 1 all to the 50th? Yay, nay?
Yeah.
Okay. Think about your substitution, kids. You know, that's going to become x squared plus 1. You can turn around and raise it to the 50th power, and it's done. We'll do one more, do it verbally. Find functions f and f of g such that f composed of g is h if h is 3 over x minus 5 to the second. I guess we will do it verbally. But what's having its action performed on it? What's kind of the inside function here? G. Well, what's inside? X minus 5 what? Why doesn't have to be squared? But g of x would be, I'd actually probably have calculated right this x minus 5 squared. F is kind of the big picture, the master function. What's the big picture here? We take 3 and we divide it by something, right? 3 over x. Now this one does have another acceptable one. That's kind of where you guys are going with it. If you let g of x just be x minus 5, then f of x would be what? 3 over x squared. That's good, Brenton. And that's kind of working backwards composition functions. And I guess we won't do that first example in the notes, but bell's about to ring. You guys have your homework. Then we'll do the same drill we always do. Coming tomorrow, I'll beg y'all what you need to see, even though you probably Slater-apped the whole blasted thing.